Well, hi, good morning, and welcome to my shop. Thank you for joining me and my cat Bert as we take another look at this radio. So right at the end yesterday, I discovered that there seemed to be a significant functional difference between the AM band and the other shortwave band, something I hadn't noticed before. So I think I kind of want to start right there and try to understand what it was I came across. Perhaps it's nothing. The way I remember it now, because it's been a whole day, is the hum problem didn't seem to appear when the shortwave bands were engaged. Is that really true? I'm having the hardest time of all trying to know for sure what band I'm on with this radio. But right now we're on one of the shortwave bands, that's for sure. What should we do here, Bert? Have you got any good ideas? Start it up, play it again, and repeat that same thing, and then ponder whether it's any significance or not. Is it a hint? Maybe. I think it has the possibility that it's a powerful hint as to what's going on with the hum side of this thing. In my own mind, my guess is the hum is coming from some high impedance circuit that shouldn't be so high, that's attached to a grid on a tube, something like that. But you know, that's just my imagination. Going along, it's really nothing you can really go on. So yeah, let's just repeat the thing and see if it is what I think it is. What do you say, Bert? You're getting all tangled up here in these chords. What are you doing there, Bert? He's on the hunt. Okay. A little slow this morning. Okay, just finished my little coffee break there. I walk in, and the first thing I think is probably what happened was I had the sweep generator sweeping the AM band, and that was probably part of what we were listening to coming out of the speaker, the pulsing of that. And then when I switched to shortwave band, of course, the sweep generator's not operating in that range, and so I don't hear it. That's probably what happened. It probably is an unimportant observation, but we have to repeat it. So I had just about everything on in here, didn't I? Isn't that what the? So I had the sweep going. I had both these scopes on. Might as well turn them on. And I don't think I have that operating. That's about it. So now we should turn on the radio. There's nothing coming out of it. Nothing at all. Cats, did you do something? Wow, there's really nothing at all coming out of it. 110 volts. How can there be nothing coming out of this? What? Oh, I hate it when this happens. Yeah, okay. There's absolutely nothing coming out of it. What could that be? The plug's not plugged in right? The set's not turned on here. How do you turn this on? With that switch there. Oh, you can see the change. So it's definitely doing something. Wow, we're off to a let's assume all this equipment's hooked up here, and that's what's causing the silence. And because I'm on a band, a shortwave band, we're not hearing anything. So okay, let me turn this down, and we'll go back to the broadcast band. Oops. I believe this is the broadcast band here when these capacitors are showing. Jimmy, what have you done? What have you done, man? Holy smokes. What? Well, I could start disconnecting some equipment that might have an impact. This would be the main one. But, wow, no. Oh my gosh, what has happened? I didn't do a thing to it since yesterday. Let's disconnect the signal generator here. Turn the volume right down. Pull this off. Might as well take this off too. That's all it was. Okay, no big deal there. We hear this mysterious hum. We're going to switch bands and see what happens to it. This cannot be from the sweep. Sweep generator's not even turned on. Okay, so we go a band. No, it didn't change at all. Okay, false observation yesterday. Baloney observation. Don't know what it was. It really. So what's that tell you then? If you can change that, but this sound doesn't change, then the sound must be coming from circuits that are not that. Must be coming from deeper in the radio. Oh, I wish I could pull tubes out and check, but I can't do that. A very strange sound. I assume you can hear it too. The pitch, the musical note that this thing plays, every time you tap it, tap the radio. The interesting thing about it is the pitch changes. There's just nothing here for me to hook onto. What was I hooked onto? Right there. Turn this back on so I don't have a dot. Well, I still have the other oscilloscope connected. That could certainly be causing something, so we'll disconnect that too. Let me just turn it down a little bit. It's actually suspicious that didn't have any effect. That's more suspicious. Can you hear that? What's going on there? So I'm touching one end of a wire, this red wire, and I'm touching the other end. Oh, I was not. Now I am. Okay. Touching the. Okay. Nothing going on there at all. Well, here we are. Here we are once again. What if I took a shot at working my way from the speaker towards, work my way back, put in, let's say, drop in an audio signal. How's that going to help? How's that going to help? I'm going to drop in an audio signal. It's pretty easy to do here. I mean, we're hearing stuff. Wow, that's really sensitive. So, you know, I'm holding the screwdriver. That's the center terminal of the volume control. That's on a shielded wire here. It comes to this location. The shield comes here. Suppose I'm trying to ground out the signal here and there, and see where the hum disappears. Ground out some grids. So nervous with these tubes that do anything untoward or by accident thing and blow a tube. Wow, this is really obviously this is filling all the gaps in my knowledge. It's right in all those zones where I don't know what's going on. Oh boy. Yeah, I gotta stop and think a bit. What I should try next. Okay, I got a gigantic long shot here. I'm looking at the volume control. I notice that it's, of course, very sensitive to interference. Right at that point in the circuit, if there's any hum capability or anything, it's going to come out of the speaker. And you saw when I, oh my God, how can I get anything done here? I'm just overrun with cats. Look at the two of them. Oh well, okay. Okay, guys, let me tell you about this radio. And of course I've lost my train of thought here completely. That's right, yeah, the hum being introduced right near the volume controller being picked up right there. So the thing about this volume control, and most volume, or many volume controls, the on-off switch is stuck on the back of it. That's just for convenience sake, of course, for operating the radio. But what that does is it brings the power wires right up against the volume control, right at a spot where the volume control is very sensitive to picking up hums. And I took a look in here. Why don't we take a look? No, we won't. I was going to say, why don't we look with the camera, but I'm busy. I'll just move this up. That's right, don't go on the keyboard. Off the keyboard. Okay, despite all the interference here, you probably can't see this because I can hardly see it. I'll point like this. So here's the volume control. Just in the back here in the dark is the on-off switch terminals back here. And there's some power wires coming in and going out of this spot. And right here is the audio wire right here, and right up against it is one of these power wires. Right against it. So what I want to do is I want to move it away. But I'm going to want to do that with the radio operating. Now, could that be the hum source? Oh, wow, I mean, fat chance. But I have to eliminate it. Oh, thanks for the pleasant view. Bert, what are you doing over there? Okay, so what I'm going to do is I'm going to turn on the radio, listen to the hum. I'm going to move these wires around. How am I going to do that with this? Not with this. Maybe with this. Move the wire up. You know, another possibility, and I'm not sure it's really, I don't know if it's a possibility or not, but see the rectifier's right here. If this isn't working right, maybe that's making it difficult for the radio to eliminate the hum. Just kind of making that one right up. So at some point I'm pretty sure, well, first I'll measure the voltage drop on this thing, and then I'll, what's over there? What'd you see? You didn't see anything. There's nothing over there. Oh man! Cats have very, very fast reflexes. In fact, fastest in the world apparently. which is why they can catch flies and sticks. Are you ready? Oh, the heck with the radio. This is way more fun. I mean, why fix a radio when you can play with a cat? You won. You won. What are you going to do now? You got it. You won. So I'm going to get rid of them by throwing this down the hall. Let's see if this works this time. Okay. Down the hall. Okay, he took 2 steps forward for a closer look. He hasn't gone any further. Man alive. Well, there was a mouse up here. Where'd the mouse go? What did you do with the mouse? That's gone too. Oh my gosh. Okay, we're going to do this with the cat here. And I have no stick. I lost my stick. Fortunately. I have another one. Look at that. Okay. Power on. You going to stay there? Hum is there. You're now going to just move the wire. Let's turn it up. Oh, that's interesting too. It's volume sensitive. Volume sensitive. It's got to be. It can't be this wire, but let's try it. No, I don't see any. No, that's not going to do anything. Volume sensitive. Hey man, that's the. There you are. That's the test right there. So the hum is coming from ahead of the volume control. Guess I'm pointing back at this transformer again. But it is the cause of all evils. Okay, so that didn't work. Of course it didn't work. Well, what if there's a thing like there's a capacitor here? I was going to say, what if there's a thing like a resistor in the circuit that's gone way high? How's that create a hum? Where's the hum come from? Where does the hum come from? Oh boy. Let's study the schematic here for a minute. The filtering, so there's 2 possible sources of hum. One is coming out of a poorly filtered power supply, so it's basically 60 cycle hum coming through. That's one kind of hum. The other kind of hum is stuff that's because our houses have wiring and there's current in the wires. We have a 60 cycle hum airborne in our houses. That same hum is inside my body as I'm standing here, and any tool or any piece of metal is carrying this hum signal from the wiring in our houses. And if you should touch such an object like your finger or screwdriver, as I did, in a sensitive part of the radio, that hum can be amplified. That is what I think we are hearing coming out of the speaker. I don't think it's a failure of the power supply. I think it's a... oh, my cat has just joined me here on the keyboard. So if we look at, well, what have they done to try to filter this circuit here? Because each one of these heaters is acting as a cathode in the tube. So if there's anything funny going on with the heater, it's going to come out of the tube. So I'm almost certain, yeah, I'm almost certain of nothing. You can't even finish that sentence, Jim. So I've augmented this capacitor with an additional 50 microfarads, this one too, an additional 50 on top of the 80 that's there, on the assumption that there still was pretty good filtering going on here, and there's no reason to remove these 80s. So we have 80s plus 50 on top of it. This one I replaced. This has a new 100 microfarad capacitor. It's newly made, it's not an old thing by any means. And where have they located this? They've placed this right at the 1U4 first tube in the radio. It's a V1 right there. This would conceivably be the most sensitive tube in the radio too, on the RF side. So they're doing everything they can here to kill hum in here. Now they've got these coils here. This is probably to react to radio frequencies and stop radio frequencies from passing between these tubes. And you can see another one of those down here. Well, these have iron cores. Well, okay, that doesn't matter. Just makes for a smaller coil, I'm pretty sure. This one also has a capacitor to help with the filtering here. This is V2. This is V1, V2. Now, we noticed that the volume control controls the hum level. So the hum is coming from earlier stages. If you turn the volume right down, I believe the hum pretty much disappears entirely. Talking about that, where's my cat right now? Oh my gosh. He's behind there. No, you can't go behind there. What are you doing behind there? Oh, for crying out loud. Yes. Ta-da! Right in front of my computer screen here I was just working on. Oh my gosh, you see, I'd grab him and pull him out of there, but you know, half the stuff would come with him. So it'd be he's got me over a barrel. That's unless I grab his legs. Do you want to come out? Or I get him to jump out on... No, don't get... No. Get out. Oh my gosh, I got tubes up here. I got all kinds of stuff. This is just terrible. Holy smokes. Okay, using your forelegs, come with me. Come with me. Yeah, you, come with me. Come on. Come on. Come on. Apparently the fish wasn't enough. Okay, I'm throwing the fish. And I've got the aluminum ball. I got the aluminum ball. You ready? Okay, let's just turn the camera. Here we go. This is it. He's going to run down the hall. This is the plan. You ready? Here, I have a fish too. Okay. See you later. See you later. It's just gotten crazy here. Okay. We were looking at the schematic, right? Let's go look at the schematic some more. So I was pondering the situation here that the volume control can limit the hum. So that would mean the hum is being introduced somewhere back here. Somewhere back here. And normally in a regular radio I'd start pulling these tubes out to try to localize the problem better. Can't do that in this radio. Yeah. We could go looking for the hum, just like with a scope or something like that. You know, look at this line here and other stuff. No. Another way would be to take a large capacitor and ground out like the grid here. Just ground this guy to nothing, and see if the noise goes. See if the hum goes away. You know, now that's not a bad idea, because you can ground this with a capacitor, no problem. You could ground this one with a capacitor, no problem. And there was something else that just came to mind. I looked down and I saw the -3 volts here, and I remembered, that's right, there was no -3, there was a +2 here. And so normally the way these guys bias themselves is once the oscillator gets going, and it should start immediately when you turn on the radio, this voltage will develop. It will develop its own bias, called a self-biasing thing. But that didn't happen. This was +2. The way I measured it, I think I measured it appropriately. That's a sign that the oscillator is not oscillating, or it's very weak. Could it be weak and hummy at the same time? Well, it could be. Could be the hum is introduced right here. Could be introduced anywhere back here, but could be here. And we're looking at two things then. Looking at something that would cause a low oscillator and hum. Okay. You know, things like open resistor and stuff like that in the circuit. You know, the problem is this is inside this box, and it's literally impossible to work on it without tearing apart the entire radio here, which I am not too happy about even thinking about. Now, didn't I test this and discover that, in fact, it looked like all the signals were present here? We end up looking at this thing again. How can I cheat my way past this? What if I try to put in my own capacitor bridge? Put a capacitor from here over to here and just see if I can get any signal through here. That's a bad move, because this is a very important filter. Only 455 gets over to here, or whatever this is tuned to. Oh my gosh, I'm just going around in circles all over the place here. I'm not really getting anywhere. Okay, if I ignore the hum and just say, well, let's just carry on with fixing up the radio, then I think the next place I would go is I would work on this string here, voltage-wise, and go through it and just make sure everything is relatively correct, which I think I did once already. We found this low. Oh, you know what I should do? Let's go after the power supply rectifier right here. Let's change this guy. At the very least, that'll boost the voltage all through here and probably restore it to where it should be. And I could make a voltage measurement across here, but there's nothing to compare it to, and I haven't told you what to expect. And you can make a voltage measurement right on here. This, do they write it anywhere at all? That says 92. That says 95. 95 on this wire. 95 on this wire. So it would be 95 whether battery or not. So this is the battery switch. I'm just thinking it's confusing the situation, but I don't think it matters because it's going to be 90 from a battery because they're 90 volt batteries. 95 must be from the power supply. 95. We have a resistor here. Well, something like 95 should be sitting right here on this, on the other side, on the output of this. We should be able to measure this and get a 95 on the meter. It's already got a big capacitor here. Let's try that. We'll see if we get 95. Okay, let's look this situation over. So this is the rectifier up here. It's mounted right on the apron here because these things do get warm, and so they're looking for a little bit of cooling. So if you look at this chassis, it's so serious they even drilled holes in the chassis, which would be kind of weird that would improve cooling. I guess you'd let a little air. I guess you'd let some air in, and then these fins will let the air up and out. So quite a serious attempt at keeping this thing cool. A replacement diode, a silicon diode, will not get hot anyway, unless you're really pushing it. Normally there's no heat issue. So for me, and for anybody doing this, the issue is the polarity of the diode you're going to put in. So we're going to try measuring the voltage here. So there's two terminals, one here, one here. I'm going to go up, I'm going to get a clip lead onto one of them anyway, so I'm not holding on to it. One of them has this big resistor, the big resistor, and then here's the switch, which I was complaining about. Let me just peek at the schematic here for a sec. The big resistor, this one is, that looks like 82, looks like 82 ohms to me, and I'm looking at, excuse me for doing this right now, 82 ohms right off the, there it is, 82 2 watt. That's on the let's call it the AC side. So this is the AC side, so the DC side is up here. We can say that. We should find 95 DC volts. Get another clip lead. And we're going to clip onto the negative, which I discovered the B minus. The great spot is right there. Hey, cat's been at this. That's a clipless lead. I'll put it over here with all my other damaged clip leads. I'm going to have a clip lead day in here. Okay, here's another one. I'm going to separate this one right now, and then this is going to go on to the negative here, the B minus. There we go. So all I got to do is just like that, and read the voltage and see what we get. 95. So cool. Some pretty good stuff on the scope there. Here we go. There's the Hummer. 95 DC volts on the end of this. Got 110. I'm supplying 114 today. 110. Well, what's the complaint about? Got the scope right here. Well, what's it look like on the scope? Watch what you're doing now, Jim. I made a big mistake there. Yeah, that was close. So this is what we get. Now you can see it from there. Look at that. It's a extremely hummy deal here. And where is that being applied? Let's just pop back on the schematic now, because yeah, let's just do this. So I'm reading it right on top of here, and this hummy looking thing. Let's see, I'm on the 1 volt scale, AC setting. It's 1 volt of hum. 1 volt in 95. Ooh, that's not good at all. 1 volt of hum. Heading up through here, I believe, all the way up, and look at that, right onto the output tube. But I've augmented this. I've got 50 on top of this. Well, can this be the cause of it? I don't believe so. Well, let's change this anyway. These guys are somewhat risky to have in your house anyhow, because if they fail, they produce a terrible acrid smoke, so I've heard. Fill your house with this horrible smoke. So we'll get rid of that. We'll put a diode in. That's going to cause an increase in the voltage over here, which is already at 110. Now there was a 1. Look at, there's a 1 water here, so we know you're dropping some voltage on this. So we really don't know for sure what the voltage should be here. I think if you're taking in an AC signal at the nominal 115 volts, that's really about 169 volts or close to 170 volts peak. And if you could perfectly filter it, you would get 170 volts here. As soon as you draw some current out of it, it would drop a bit, of course. You have some kind of a drop on this. When I augmented the capacitors here, it seemed to me it made no difference in the operation of the radio. There is a certain amount of hum you can tolerate in an output tube circuit, because it's a relative thing, and if the hum is low enough, you can't hear it or you don't care about it. So sometimes they send poorly filtered power to the output tube, and I want to send much better filtered power up into the earlier stages of the radio, it's much more sensitive there because of all the amplification that's coming. So on that basis, then we see the choppy signal here. You gotta wonder what's happening out here and out here. This is easy to test because it's right in front of me. Let's put the scope here and see what we got with my nice capacitor there. Okay, so I want to move the scope to the little capacitor. It's right here. So I'll leave this hanging open, and we're just going to connect onto here. Nice straight line here. A 1 volt scale. 0.1 volt scale. Pretty straight line here. Get down all the way to 10 millivolts, and now you can start to see something, but there's noise and everything in there at the same level. There's no hum at this point. There's no hum at this point, I would say. And let's disconnect. No hum. It kind of throws us back to the first thing, which is the hum is a picked up signal. It's not being delivered by a hummy power supply. It's being picked up by some antenna-like thing happening in here. I need to work my way either, from the later stages in the radio towards the first stages and look for the hum to disappear. Assume the hum is all through the radio, and what's happening is the hum is impacting very sensitive circuits, and that's why it's coming out of the speaker. But the hum is throughout the whole radio. That would be a power supply thing, but I'm kind of convincing myself that's not the case. An open resistor on a grid circuit somewhere. Power off, please. Coffee, please. Okay, here's my idea here. Volume control's here. Volume control controls the hum, so the hum must be ahead of the volume control. That's all this stuff. What I'd like to do is get a fair size capacitor and one by one ground the grid into these tubes. So I put the capacitor here and just by hand and ground the other side to the B minus, and in that way eliminate the signal at this point. If we eliminate the signal at this point but still hear the hum, then we know it's somewhere up in here. On the other hand, if we eliminate the signal here and the hum disappears, then we know the problem is back this way. That's kind of what I'm thinking. And we could do that on a number of tubes. You can ground these out. There's no danger in it. We kind of know the signals here from earlier testing. Wow, just everything points back to this transformer that I put in there. Was the radio humming before I did that? It may not have been. How would that introduce a hum? The way this would introduce a hum is if this is open. In fact, if there's something incomplete about this circuit, you would get the antenna style hum, if I can call it that, or the open circuit hum, or the high impedance hum. Wow. Okay, well that's an idea anyway. We'll do that. We'll ground this guy out. Now, can I ground anything else out with a big capacitor? I could ground this. It's just a capacitor, so it won't draw any DC. Okay, that's an idea. I'm going to drink coffee and let that idea percolate a little bit before I actually try it. Sometimes certain things take a long time to notice, but this is the tube I was going to start the first test on to see about the grid. And I look down and go, it's a V1. Well, no, V1 is up here, isn't it? V1. V101. Oh, I don't remember seeing a V101 and a V102. Okay. Let's look at the schematic here and just see how far off I was. Way down here. Oh my gosh, look at all this stuff. Here we are. So, V102. V1. Oh my gosh. If I ever had my head turned around here, I don't think it's had any impact on anything, but I just assume V1 is this one over here, V101. So I don't think it's caused me any trouble. But and interestingly enough, V101 and V1 is the same tube, 1U4. So even if I did get them confused, I still would have the same pin out. Lucky me. Okay. Wow. Takes a long time for me anyway. Gather up all the information here and get it straight into my head. So still, we're going to be quelling the grid on V1. I can't get at these guys. Well, I can, I can put the tube extender in. I can get at these guys too. But let's start out here, a little closer to the volume control. We'll pick V1, and the grid is pin 6 on V1. Pin 6 on V1. Okay, V1 is here. Pin 6 should be easy. Let me take these clips out of here. Oh no, here he comes again. I thought you went to bed for sleep, didn't you? You just know when to come in here, right when the action's going to start, right? Okay. Okay, here we go. Checking. Oh, I forgot what. Totally. Wait a minute. What I was going to do was. What was that? I was going to use a capacitor to kill these grids. I can't remember. 2 minutes. That's because of you, Cat. You keep coming in here, and my mind just goes blank. So I have a tool for that. Okay, I'm going to hunt down my killer tool here. Okay, this is my killer capacitor on a stick. This is a fairly small, it's a physically big capacitor, but it's only a 0.05. It's a little bit small for this. The one lead is sticking out here. The other lead is connected to the B-. I'm just going to touch this against the grid of this tube, and we're going to listen to what happens to the hum. I wish this was a little bit bigger, but we'll try this anyway. Now which pin is it? Just to be absolutely sure, I'm looking at this tube, pin 6. Pin 6, and then identifying pin 6. Hey, where'd all my sticks go? Notice it's completely quiet in my house now because the cats have gone to sleep. So the craziness is over. And they'll stay asleep for a few hours, that's for sure. 1, 2, 3, 4, 5, 6. 6 is coming right from the transformer here. Count them carefully because it's easy to count them again. 1, 2, 3, 4, 5, 6. Yep. So practicing. Touching that. I can do it over here too. Will the hum disappear? My guess is no. My guess is we won't hear any effect from this. That's my guess. It's a bad guess. Okay, hum buddy. Here we go. Pin 6. So the loud pops was the charge building up in the capacitor. Now the capacitor's charged up, so you don't hear the pops anymore. You might hear one now. No. So, any effect on the hum? Nothing at all. It would affect it. I would expect it to have some kind of effect. So that suggests the hum is not there. The hum is not there. Well, then we'll just go down to the next tube, I guess. So the next tube, though, is an audio is an audio tube. So this would be right on the output of the volume control. If you notice, look at this, there's a 0.01 capacitor right here. And if this capacitor's lost its capacitance, it's turned into a resistor or something. That would explain low volume, but it doesn't explain where a hum comes from. Keep hunting. Let's keep hunting. Hum hunting. Okay, touching the center tab of the volume control. Well, that sure did the trick, didn't it? Okay, touching the input side of the volume control. On one side of a capacitor here, you hear the effect. Other side of the capacitor, pretty much the same effect, eh? What else can I poke around with in there? The other side should be just kind of a ground. Yeah, it doesn't do anything. Okay, so we know the hum is being presented. Maybe that means it's an audio. Obviously it's an audio hum that's coming out of the speaker. Maybe its source is even in the audio circuits. Why would you think that? That doesn't make sense. That actually, I'm proving the opposite. But the hum is coming from earlier stages. So I've touched the grid on the IF transformer, on the IF amplifier, and the result was we didn't notice anything. So if I the detector tube, let me look at the schematic here. So we go to the detector tube. I could so what have I done so far? So I've killed this, and the hum disappears. I'm all confused. I killed this, the hum. No, I killed this, it makes no difference. I killed this, it makes no difference. Kill the output of the volume control. Hum goes away. What if I just poke around here? Just keep poking around. How do I do it on the heater strength? Why don't we try that? Put a little capacitance on the heater strength. So this is pins 1 and 7, 1 and 7. Pins 1 and 7. And the oh, I'm not sure which tube's which. Just a sec here. I think I've got another. Stupid of me. I put 2 tabs on my browser here so I could flip back and forth, and then I scrolled the one. Whoops, I scrolled it way past where I want to go. What am I doing? I'm looking for this. Okay, so now what I wanted to check is fooling around here. So I could do pin 6 on the 1U5, and where is the 1U5, just to be sure. Whoops. V2. Wow, they're calling this tube V2. V2. So V2 is this guy here. And the pin number that I want to quell is pin 6 coming into it. What's the same as the output from the I'm on the other side of the output capacitor from the volume control. Let's go on pin 6 of that tube there. Pin 6. Uh-oh. Pin 6. Oh, it's buried. It's buried underneath there. 1 in 7. Wasn't it 1 in 7? What did I talk about? I talked about putting the ground on the heater string. Just stick the capacitor on something, for crying out loud. Heater string. Oh, but I bumped there. Careful, man. Doesn't make a hill of beans worth of difference. I can see pin 6. Oh, there's all kinds of stuff going on right in here. Okay, we're going to try to touch pin 6. Best way is in through here. Doesn't make any difference at all. Let's try it here now. Oh. Okay, that's the charge. What am I doing now? Look at the schematic. What have I done? So I'm quelling this. The hum is disappearing. It means that it's coming from ahead. So it's the same thing as doing this. And I've done the input, and it's there. Let's just keep going back. We'll go back to this 2.2 megohm resistor, or end of the shielded cable. So 2.2 is right here. That's quite a difference. Now 2.2 is a big capacitor. So on this side, the hum is still there, it's just greatly reduced. So the hum is at this point, but not much left of it on the other side. Am I getting this right? So if this is the input side, or what do you want to call it, it's connected to this little 3-part package. So here's the 3-part package. I'm touching here. So this is and then I'm going on the other side of the 2.2 and not hearing it. Not hearing it here, but hearing it here. So we need to quell it up in here even. So the hum exists at this point. It cannot be heard on this side. Let's go on the other side of this filter, and that would be on the bottom of this. That would be pin 2. Goodness knows which one's pin 2. Okay, what are we doing again? I turned around. Room effect. You know that effect where you go to a room to get something, and when you get there you don't know why you went in the room, you can't remember? That's a normal biological thing because your memories are tied to geography. It affects me so bad at times that I can open the fridge, stick my head in the fridge, I can't remember what it is I'm looking for in the fridge. The room effect inside a fridge. It's happening here where I'm turning and looking at the schematic, and then I'm turning and looking at the radio, and my memory's getting erased in the meantime. Now, what am I after that little discussion, what am I doing? I'm going to quell either side. The center lead is a ground. There's a little tiny green thing here with 3 leads. This is the output. So that's it. And this is the input side to it. This is the output from the detector. Gee, if we were trying to receive something, would we be able to hear it now? Because I've got rid of the hum. Probably getting rid of everything, including the valuable signal. So if we want to go back further, we're right here now. We can hear this. I quell this, the hum disappears. So the hum must be present here. So is it present here? So I will quell this part of the circuit with the capacitor. All we got to do is get on V1 pin 2. That would be the best one to do. V1 pin 2. Okay, so V1, I just don't want to trust my memory. V1 is this guy here, right? V1. V1 is this guy here, and the pin we want to go on. Get on. Well, we could try 4 on the tube. I'm not sure I know what I'm doing here. 1, 2, 3, 4. Nothing happening there. Okay, so we would look at what that's connected to. Pin. What are you talking about, Jim? I'm really losing it here. Let's back up a little bit. So this is the so I go on the other side. Right, pin 2 V1. Wow, I tell you, man, coffee's just not strong enough. Pin 2 of V1. That might make a pop. Interesting. No hum here to be quelled. Or my queller's not big enough. So that's pin 2. That's this right here. So conceivably drawing the hum out of here, but it didn't make any difference. No hum here. Maybe this is high impedance now. If we measure the resistance from pin 4, we should go through this coil, through this resistor. We can measure it to this point. I know where this point is, and we should find 47K and a little wee bit extra, about 50,000 ohms here, from here to here. Let's do that test. Yeah. Okay, let's measure this resistance, and we will see. Find out if resistance is really futile. So 47, okay, plus a couple for the coil. Now I gotta make sure I put these leads in the right spot. So we're trying to run through this one here. So we would start on pin 4 of V2. Pin 4 of V2. Pin 4. Put this on here. Ooh, maybe I shouldn't use a clip lead. This is a resistance measurement. So pin 4. Oh gosh, it's going to be tough to get to. 2, 3. It's right underneath this thing here. Pin 4. Oh boy. If I can't get it there, I can go right on the transformer and pick off pin 1 on the transformer. Pin 1, I don't know which one's pin 1. I can't see the green dot. Okay, we'll have to figure that out then. So one of these is connected to the little thing here. That's it. That's it. That's all I got to do. Just touch there. I'm just reading basically across this guy here. It's basically what I'm doing. Okay, I think I know what I'm doing. Jim, do you know what you're doing? Yeah, I do. 47. 54. There you are. So, okay, that's not the problem. This resistor is good here. What if this is not likely to have a problem? Yeah, but I'm in a situation now where the whole problem is not likely. So I should really check this too. 1 meg to ground. AVC resistance to B minus. Yeah, that's AVC, and B minus is right here. So right here. So what kind of resistance do we get here? Check my meter. So we're getting around a megohm here. Megohm, and that's exactly what it should be. Megohm. Okay, now working towards this how would this ever be responsible for a hum? Because we're thinking about this being ungrounded or floating high. What about this? What about these guys inside here? 250 picofarad capacitors. What would happen if these were open? They wouldn't quell the RF. They wouldn't generate a hum, though. This wouldn't generate a hum. You know, I got to be careful now because you know, I'm having trouble finding the problem, and part of the problem is going to be the way I'm thinking. Inevitably, if I think a little different, I might find it quicker. So I have to be very careful about thoughts of, you know, that can't be the case. And those kinds of thoughts I really shouldn't be having. So I should really check. I did check this. So short-term memory. What's going on with this deal? 10 meg. No, this is normal. This is how they usually do this. You find a very large resistor right here. Very large resistor. Now, if this capacitor is not got its capacitance, then this would float high, like it would be high impedance, very high impedance. We need to check this capacitor right here. We need to check this capacitor. Now, think about it. The hum was related to the volume setting, but another aspect of the volume control is you've got a ground here that you're applying to this by turning the control. For instance, now the hum didn't go up and down. It did go up and down. It goes up when we turn the volume up. That would mean the hum is in this. The hum is in this, and it was a normal thing. Turn the volume down, it goes away. So the way you turn the volume down is to move this over this way. Then you get, no you don't, and then you get full volume. You move it this way towards the ground. Hey, what if this is open? The ungrounded volume control. Da, 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 da. Some feedback coming in too. Oh, it's all these switches are fooling around with the feedback coming back from here. The purpose of the feedback, first, if you're not familiar with this, you might think, feedback? What are you doing? Feedback, see, it says right there. Feedback. What? Doesn't that cause a squeal? Well, this is negative feedback, and what it does is, and it's almost like a miracle, it will clean up an awful lot of harmonic distortion and stuff that's going on in the signal as it arrives at the speaker. It's almost like a magic trick. This is figured out in the late 20s, I believe. That you could do this kind of thing. Won't get into it any further than that. Shouldn't be part of a hum problem unless it's feeding back a hum from out here, which is kind of hard to understand too. So let's stick with this. We'll find C7. That should be easy to find. And oh yeah, you can see the radio. So C7 on the volume control. This guy right here. This is the guy too. When I took the snuffing capacitor, went here, I got exactly the same response. But this is a highly reliable kind of capacitor. This type. 0.01 written right on it. So let's lift it and test it. I think I'm just going to nip it off there because it's got lots of leads to go back on. And I'm going to nip this. And then Okay, Mr. Capacitor, let's test you. We'll test you with this guy here. These are generally very reliable. These ceramic capacitors. 0.01 would be the magic thing. Okay, so it says it's 10 nanofarads, and that would be a 0.01. So, boop, we didn't win here. We did not win the contest. Nothing wrong there. Phooey. Just really hoping we found something. I have it disconnected now. What can I do with it disconnected? I don't think it's in any way an advantage, so I'm going to reconnect it. And the radio shows this. For some reason to leave this off just now. Let's look at the schematic here. What am I actually disconnecting? I'm disconnecting. Can't be this. I got the wrong capacitor. I think maybe I did this one. What am I doing? It's right off the center, isn't it? Or am I seeing it wrong? Oh my gosh, I'm seeing it wrong. From here, you'd swear it's soldered to the center terminal, but if you just turn your head and look like that, you see it's not on the center terminal. This is this capacitor. 0.01 also. Okay, so we'll put that back on because I picked the wrong one. That's good. That means the chances are my earlier idea. Look at. If I had just put this back on, I would never realize I did the wrong capacitor, and would have had it in my head that I dealt with this when I hadn't dealt with the correct capacitor. Let's get on there. Just a little more, please. My stomach complaining so much. Maybe you can't hear it. I suspect you can hear just about everything I hear. That's what I think. Come on, get around there. That'll do it. There. Where is he? Ah, it popped right off. I thought I had it on there. I don't think that's gonna. I'll have to push it on. Okay. Okay, that's back. Now, how about doing the right one, Jim? Okay, so you can see the center here, terminal, and there's no capacitor up here, so we got to go to the other end of the cable. Oh no, it's under this green thing. The other end of the cable. Somewhere. How much you want to bet that's the 0.01? Anybody want to bet on that? It's a point. No, it's 0.05 or 0.01. I think this is probably it. Oh boy. Okay. So we can reach the capacitor. Look at the schematic again. We can reach the capacitor by testing between here. Where's this 10 meg resistor? Let's see if I can find that. 10 meg would be brown, black, green, wouldn't it? Brown, black, green. Brown, black, green. Somewhere in this area. Brown. That's got the blue. Brown, green, red. No. Brown, black, green. Wouldn't that wouldn't be right, would it? Because brown, black, green would be 1 megohm. Brown and black was something else. Brown, black, red. Brown, black, brown. Ooh, there's one hidden in behind here. Yellow, black, green. Yellow, black, green. Blue, gray, black. Brown, black, blue. There it is. That's probably the one there. Brown, black, blue. Yes, I even have a cheater card here. Blue. What is blue? Blue is 6. There you are. So that's the resistor that's hooked up to the capacitor that I'm after. So we know where the 10 is, and one leg of it should be connecting to the capacitor. It's all hidden behind this crazy thing here. Yikes! And I haven't talked much about this green piece here that you can see. Come a little closer. So this is the early stage where electronic companies, parts makers, were starting to put more and more parts into one package. So the radio manufacturers could buy a package, a square thing with 4 or 5 parts in it already. And that's what this green thing is. And then there's another green one here. This is the one I was testing earlier. This is to simplify the radio, easier to build, and the parts manufacturers knew that these kinds of parts were required in almost every radio. So they sort of standardized them, and there they are. The difficulty is there can be a defect of the part that's inside this package. And in that case, sometimes you can do something outside of the package to compensate for the part that's defective inside. Other times, the whole package got to come out and all discrete parts got to be put in to accommodate it. Is this the cause of problems? Well, it's causing me a problem right now because the big square thing is blocking my view of everything I want to see. Here. Whether it's in any way implicated with the hum, I don't think so. So we're dealing with the idea that this capacitor, there's no other, well, there's this one here too. Big Hunts capacitors. These are unreliable. These guys here are, let's say, less reliable than something like that. How much you want to bet it's one of these? Put your money down. Okay, let's put some money down on this. Here we go. I'm going to put down a. This is Castillo de. I can't read it. It's some kind of a fort or something like that. This is Republica del Cuba. This is a Cuban coin. Okay, 10 Cuban, whatever it is. 10 Cubans. Okay. So what am I betting? I'm betting that the capacitor, when I find it, will be will have no capacity in it anymore. That's the theory, and then it becomes like a high resistor, like a high value resistor, and that's a little like an antenna, and that's where it gets the hum. Ooh, that's quite a theory you got there, Jim. So we're looking in here at the schematic, and we see that. So this is coming right off of here. They even show that the shielded wire's here, and then you reach the capacitor. This capacitor is probably mounted right on this pin here. That would be my guess. Now, where's that tube? So that tube is right here. Everything's right here. So there's another capacitor right here, but that looks like a much smaller one. And I can't see the size of this one. Hey, let's look at the diagram. The diagram may help. Well, these pictures are lousy, but it might help. Okay, so here's the package showing here. And I am looking for C7. Looking for C7. Yeah, C7. C7. It's the one I figured was it. So this is a highly reliable capacitor. Now, how could we possibly test this? Well, I can't even get at it. I didn't want to disturb this stuff very much, for fear it's fragile in some way. So, okay, let's look. So this is it. Let's look more closely at this guy. Oh yeah, great. Okay, can I see the leads on it? So one of them, interestingly enough, they've put a sleeve over one lead. Of course, it would be bare otherwise. And then, so I can see where that's going. Can I really? Yes, I can. I can access it also. Okay, that's good. And the other lead. Oh boy. The other lead comes here. Okay, so now it's in a circuit, so what I'm going to do is really not very valid unless we really take a good close look at it. So one lead was coming here. That's right. And the other lead is coming here. Okay, let's see if we got anything here. What do we got? What's it think it is? It thinks it's a capacitor. 12 nanofarads. So that's pretty close to 10, isn't it? Or 0.01 rather. 12 is close to 10, but 0.01 microfarads. So that tests fine. So that eliminates that possibility. So we found that this capacitor is probably fine. This resistor, it's very unlikely anything would happen to it, but again, don't think like that, just test. We need certainty at this point on everything. So, testing the 10 meg resistor. I think we can get it like this. There you are, 10 megs. Okay. Remember that volume control controls the hum. So I'm kind of on the wrong side of the volume control here, looking for sources of hum. Wasn't I going to check this? I was going to check this. What happened? I forgot about it. R7. Let's find R7. I think I forgot about that. Blame it on the cats. R7. R7, here we are. Okay, R7 is there. R7. So R7 is up in here. I think that's R7 there. So this one is I've got the light turned up in my shop here too much. So that looks like gray, red, brown to me. This one here, gray, red, brown. What's gray? Gray's a big number, like 9 or something. R7. What's the value of R7? R7 1.5K. Doesn't add up. 1.5K should be brown, green, something. Brown and green. Brown, green, and brown. Here we are. Brown, green, red. Right here. Here it is. What's it doing over here? So there's another one like that. Not the only one. It's on the wrong tube, isn't it? Tell me I've been looking at the wrong tubes here. No, I'm pretty sure I haven't. Way in behind. No, oh, there's one right here. That's not brown, black, blue. Brown, black, blue. Wait a minute. Brown, black, blue. This is after the 2.2. Okay, totally lost. Totally lost. My brain is just fried here. We were trying to track down. Well, we were going this way. I forgot what I was doing. Oh, going after this. Looking for R7. Right, 1.5. So they should be right off the volume control here, isn't it? Yeah, that's where I am. I'm up at the volume control here. There's a brown, black, yellow, and a gray, red, brown. Gray, red, brown would be something like in the hundreds. Gray. It really should be brown, green. I don't get it. Somebody show me a brown, green. The only one's way down here. That can't be right. Something funny going on. Let's go back on the diagram here. We definitely are just double checking. It's R7 1.5K. R7 1.5K. Where did I find it here? R7. So here we see two resistors, one going this way, one going that way. One going this way, one going that way. This comes down to a terminal. There's a little capacitor here. Where's the big one? There's a big one in the diagram, laid right in here. It doesn't show. See, right here. This is the terminal strip. This is the capacitor laid up against it. It doesn't. It just have a little tiny guy. Okay, well, who's to say that? Who's to say this diagram is 100% for all radios? I mean, they would change the radio as they manufacture it a little bit. So we have the bigger capacitor here. That turns out to be this little brown one here. So I think what we're seeing is these are wax capacitors. This one doesn't. These are wax capacitors here. And later they changed them to molded capacitors of this sort, because there's no waxy capacitors in here anymore. So I think that's what we're seeing. Okay, so this is R7, and there was a note somewhere about some resistors being different in size. R7. Is there any chance that that note that I'm remembering has to do with R7? Is there any chance of that? On some sets, C11 is 220. On some sets, this lead's connected to pin 7 instead of pin 7 of the one. That's it. That's not much. So I'm in a funny situation here now. The schematic is telling me 1500. How much is that? This one here. What is that actually then? Well, it'd be gray, red, brown. Let's measure it. Just use my own meter here. Just put it like that. Gray, red, brown. It took me a while to remember what I was doing again. Wow, I'm getting old. That's what's happening here. Ooh, this is showing up Okay, this is the proper scale. For a moment it said 1400. 8, so 900 ohms. 900 ohms. How do you get 900 ohms? Well, it's in the circuit, so maybe that's what's happening. But gray, red, brown would be, what's gray? Gray is gray 8? I don't remember. Gray, I don't, the high numbers, I keep forgetting what they are. Gray. Which one of these is gray? Black, this must be gray. 8. So we're looking at a resistor 820 ohms. 820 ohms. And that's what we're measuring. Why not 1500? We can only guess that they made this change somewhere down the road. Yeah, so it reads 900. It says 82 on it, 820. So that's okay. What else we got happening there? I end up going through every component in the radio one by one. That's not good. A little worried about these inside here. But again, it doesn't explain why the hum comes from a high, in my estimate, a high impedance circuit where something has gone open. Then we could just track back here. Now, have I tried quelling the sound in a year? Did I do that? I don't remember. Oh my God. Maybe it's time to stop today. Let me recap. I'm working my way through the circuits, almost one component at a time at this point, looking for some evidence of an open resistor, open capacitor in a grid circuit in the earlier tubes. That's what I'm actually doing. May not look like it. Doesn't feel like it at times. That's what I'm trying to do. I think I'm going to call it quits here, and we'll continue the search tomorrow. Just work on a few more tubes. And what I find in situations like this, where I cannot personally just track right into the problem and find it, that it's a matter of stumbling on it. And so I have to just keep doing stuff until I literally stumble on the problem. Doesn't sound very good, does it? Okay, well, you have a great day. I'm going to continue with my around the house projects today, and I'll be back in here tomorrow morning. So thanks a lot for watching. Sorry this is such a runaround, but it is what it is. I am who I am. I am what I am, and that's all what I am. Yeah. See ya.